In this video, we're going to take what we learned in the last video and apply it to this application to make a service layer. Alright, so what do I mean by a service layer? Well, basically, what we have right here so far is a single tier application. And what I mean by that is pretty much all of the code we have, for example, our profile activity, all lives on one sort of architectural layer. And in this case, it's the UI layer, the user interface. As you see in the profile activity.java class, or file, we have a bunch of logic here, and quite a bit of it, in fact, but it all has to do with the user interface. All of this logic is simply gluing into Android and manipulating the user interface in some sort of way. We do things like change our state, we handle screen rotations, we show our contextual action bar, and we handle option button clicks, and all that UI stuff that ties into Android. And so our application right now is very flat, very one-dimensional, because we only have UI logic. However, there's another kind of class of logic that we might want to work with, and that is the logic of our business logic, the logic that actually does something. For example, actually changing our profile. See, right here, we see a bunch of code that handles the user interface for how the user is going to type data into the profile screen, but when we hit the save button, what happens? What logic gets executed to actually perform that operation? And that is what we typically would call domain logic or business logic. And what I'm going to do here is I really want to decouple that business logic from our user interface code. Because you see here, we already have a lot of code. And we, like I said before, all this code fits together because it lies within the same architectural layer. It lies with its all UI code. So it makes sense for this code to live together. But if we started adding business logic to this file, we can imagine it starting to balloon in size. And then we have a mixture of concerns. So we have our user interface code, then we have our business logic, then more user interface code, then our business logic. And then it becomes very difficult to change either the user interface code or the business logic separately without damaging or breaking some other piece of code. So, what do we do? Well, the standard practice in a object-oriented language, or actually really standard practice for anything, is to break our code up into more architectural layers. So the idea is that we have our user interface layer, and it stays here. It stays how it is, how we've written it. But the code that actually does things, does things like upload an image to a web server, the code that does things, the business logic, is going to be set to a different layer. It's going to be written in a different layer that'll be isolated from the user interface. So we'll have our own set of classes that deals with the actual doing of things that'll be separate from the user interface that handles showing things. And that's basically what I'm going to be referring to as our service layer. So our service layer is a collection of classes that performs our business logic that knows nothing about the user interface. So that's all well and good, and you might be asking, okay, so why don't I just start writing my service layer, start writing classes to do things? I mean, we already have some to-dos in our profile. For example, we haven't done anything with uploading our avatar. We haven't done anything to update our display name and email, so why don't I just start writing classes that does these things and be done with it? And furthermore, how does Otto tie into any of this? Well, the answer is Android presents a very unique challenge when working with activities. Activities, like I've been really liking to say throughout the series, are islands of functionality that are self-contained and contained the M, the V, and the C, the model, the view, and the controller, all in one class. And the way that Android is designed really to be worked with, or the way that the people originally designed Android to be worked with, requires basically mixing all your concerns into the single activity class. The problem with that is we've run into some challenges with how we can introduce a robust service layer. And this video is going to be all about writing the infrastructure code to handle a service layer that'll behave in the way that we want and will allow us to describe our service layer properly throughout the rest of the series. So we're going to be laying the groundwork in this video. So what kind of challenges are we going to be facing here? Well, the first challenge is going to be pretty obvious, or well, maybe not obvious, because we have to start talking a little bit about how Android deals with threads. Now, in an Android application, there's by default going to be one thread that you have to worry about, and that's the main thread, the UI thread. And on that thread is where all of the rendering, the changing text on your text fields, the getting the edit text out, basically everything you see right here gets ran on a single thread. And now that's all well and good. I mean, honestly, it's multi-thread UI code is actually a bit of a nightmare. Having it all on one thread is awesome and makes everything synchronous and simple to easy to understand, and you don't run into as many race conditions. However, it poses a problem when we might want to have some code that takes longer than a couple instructions to complete. For example, networking. Now, as you see right here, we have a to-do here. We want to send the temp file URI to the server. So we want to upload an image. Now, uploading an image isn't an operation that'll complete immediately. It's so as a result, what's going to happen here is we have two options. We can run the code that uploads the file to the server synchronously or asynchronously. If we run it synchronously, what do I mean by that? I mean that we perform the actual upload literally on the UI thread. In fact, Android will not stand for that. Android itself will throw an error and tell you that that is a bad idea. And the reason why it's a bad idea is because you don't know how long that operation is going to take. It might take 100 milliseconds, it might take 5 seconds, right? You don't know how long it's going to take to upload an image to some remote server somewhere possibly in a different country that may or may not even be running at the moment. So what do you want to do? Well, you want to execute this request asynchronously. As in, not synchronously. Basically, you want to fire off a request on a different thread somewhere and say, send this image up to the server, and when you're done, or when you have an error, tell me about it, notify me about it. That way, we don't block the main thread. Because blocking the main thread would, like I said, what is the main thread responsible for? Event handlers, rendering our activity, some animations. I mean, if you blocked that, if you waited for network requests to complete, your application is going to stutter. It's going to be completely 100% frozen until that network request comes back. So that's what the importance of asynchronous programming is. So that's awesome. So we'll go ahead and start doing asynchronous requests, and everything will be great. Well, except there's certain things with dealing with asynchronicity in Android that is annoying. There's a couple built-in tools to deal with this sort of thing, things like loaders or async tasks, but I found that using Otto makes for a far more consistent experience. And so I'm going to describe in this video and show you guys what I mean by how we can use Otto to basically handle this problem, the asynchronicity problem, as well as a few others. For example, what happens when the asynchronous call finishes? So, for example, what happens when we publish the synchronous call right here? We upload the image. What happens if that asynchronous call finishes? Well, you might say, well, it'll invoke some method on the activity to make the activity know that the asynchronous call is done. Problem with that is activities are fairly transient in Android. As we talked about in the three-parter mini-series about Android activity life cycles, activities can be paused, and they can be destroyed, they might not even exist yet, and so on and so on. So how do we deal with that? Well, we need a reference to this activity, but what if it gets destroyed and recreated? So we rotate the device, the profile activity gets destroyed and recreated. When the asynchronous call comes back, what object does it use to tell it that the avatar was uploaded? Does it use the old object? Well, that activity no longer exists because the activity was destroyed when the device was rotated. Does it use the new object? Well, it doesn't have a reference to that object because that new activity was instantiated while the asynchronous call was happening. So how does that work? So that's another really big problem with the way that that we work with the synchronous code in Android. The final issue that I resolve with using Otto for our service layer, to abstract our service layer, is with replacing implementations. So you guys might be familiar with the concept of interfaces, inversion to control, dependency injection, all that fun stuff. You might be saying, well, that's a solved problem. Well, yes, but let me go ahead and, for people who haven't heard of these concepts, describe what I mean. When we're testing, when we're going to be building this app, and also if you wanted to write automated unit testing, you would need to have a service layer, an actual service layer that does things, but you wouldn't want it to be the real service layer that actually does things. So what I mean is you want a fake service layer that basically returns dummy data, but doesn't actually connect to the internet. And so that way your tests can always run. You don't have to be connected to the internet. You don't even have to have a web server. In fact, you could develop the entire Android application without a single web server, and then base the web server on the API that you ended up wanting to use from the Android application. That's perfectly valid. In fact, I'm going to do most of this series, the rest of the series, without even touching the internet, just using a fake service layer that will allow us to test things really easily without having to deal with the existence of a web server. So how would we accomplish this? Well, you might say, okay, so we would create an interface. Like, let's say for our profile activity, we would have an iProfile service. Or, well, in Java speak, it would just be a profile service, because Java doesn't prefix interfaces with I, unfortunately. Or that's the, doesn't normally. Anyway, so you'd have an iProfile service, and it would be an interface, and it would have a method, for example, update avatar. Then you would have two classes. You would have a in-memory profile service and a real profile service. And there would be two classes that implemented the same interface, and then you would switch between them depending on if you wanted an in-memory implementation or if you wanted the real implementation. And that would be fine. Well, the problem with that is it requires additional infrastructure to put together, and I don't want to really deal with that additional infrastructure or bring in an IOC container or anything like that when we can accomplish the same thing with events. So I finally come back to how it is that we are going to be writing our service layer. Basically, what we're going to be doing is we are going to be having a auto event buzz. And for every single service invocation that we might have, like, for example, sending the temp file URI to server as new avatar, we're going to create two classes. One class is going to be the request class, and it's going to contain all the information that's needed to send this request to the server, or to the service, rather, because it may be an in-memory implementation of the service or a production implementation of the service. Now, that request object, that request event, will contain all the parameters needed to fulfill that request. So in this case, it'll contain the temp file URI. In the case down here, it would contain the display name and the email. Then, the service layer will go off and do its own thing, on its own thread, whatever it needs to do. And when it's done, it will publish an event, another event that corresponds to the response of this. So in this case, we'll have a request and a response class. One event is for the request, one event's for the response. Then, on the activity that initiates those request events, he will subscribe to the response event. So let's go ahead and I'll just go ahead and show the code. It won't be a whole lot of code. We're basically going to be modifying our application class, and we'll be modifying we'll be adding a new class into our application, and then we're going to be writing a request class and a response class for, in this case, these two things. Well, also we'll also need to do that for our change password dialog. And then I'll show you guys before we actually write the service layer. And then in the next video, we'll go ahead and we'll write the service layer to put that all together. So yeah, let's go ahead and get started. First thing we need to do is open up our Gradle application, because we're going to be using the Otto library in order to do this. So let's go ahead and add a new dependency, calm dot, and then we're going to do square up and colon Otto. And for the version, we're going to do :13.6. Semicolon is optional, so I'll remove that just to be consistent with the rest of the compile statements. Okay, so go ahead and sync your Gradle file, and it'll pull down Otto. Now let's go ahead and create our bus. So where does our bus go? In this case, we already have, remember our bus is kind of a singleton object that orchestrates all the events. and subscribers and producers, we already have a very convenient place to put our bus, and that is our application object, because our application object is known by all of the actors, the activities, the fragments, the dialogues in our application. So inside of our Euro application, I'm going to say private bus. Then I'm going to go ahead and create a public Euro application constructor, and I'm going to say bus equals new bus. And then all the way at the bottom of the class, I'm going to say public bus get bus return bus. So that will allow us to acquire the bus in the entire application. So that'll be awesome. Okay, so what's the next thing that we have to do? Now that we have our bus, we need to make sure that all of our activities are registered with the bus. So what I'm going to do here is I'm going to go ahead and inside of my base activity class, so I'm going to jump all the way into the base activity class, which of course is under my activities. I'm going to go ahead and put together a really simple rudimentary implementation here. And we'll expand on this in the next video. So I'm going to create a new field, protected bus, and then on create, right after we get a reference to our application, I'm going to say bus equals application.getBus. So our bus field is just a convenience method. Then at the end of onCreate, I'm going to say bus.register this. So I'm going to be registering the base activity on our onCreate to the bus. Then I'm going to create a new override method. And again, we're still on base activity. And I'm going to say protected void on destroy. And I'm going to say, first thing I'm going to do is super on destroy. Then I'm going to say bus.unregister this. Okay, we'll talk about this more in the next video, but you'll notice that I'm registering and unregistering the bus on onCreate and on destroy instead of on pause and on resume, which is commonly recommended. And we'll talk about why I'm doing this in the next video. So let's go ahead and also do the same thing on our base dialog fragment as well as our base fragment. So again, it's the same thing. I'm going to create a protected bus. After getting our application, I'm going to say bus equals application get bus. And then, of course, I'm going to say bus register this and override public void on destroy, super on destroy, bus unregistered this. Okay, so now we're registering and unregistering our base dialog fragment, so our dialog fragments can take advantage of our event bus. Now let's do the same thing to base fragment. I'm going to say protected bus equals application.getBus. I think I'm being inconsistent here with my... Oh, no, I'm not. Actually, I want to go ahead and just change my line spacing right there. I think that looks better. A little bit more balanced there on the eyes. I just did something that's completely irrelevant to the functionality of the code, but I like the aesthetics of properly adding in new blank lines. I just do. Okay, so now we have our base fragment being registered and unregistered as well on the onCreate and onDestroy. We'll throw in some more code in these three classes, the base activity, base dialog fragment, and base fragment in the next video. But for now, this will do. So, now enough things are in place. So you guys can already see how the Euro application has the bus, instantiates the bus, and makes the bus available to all of our activities and fragments. And then our activities and fragments register themselves with the bus and on destroy unregister themselves. So now let me go ahead and show you guys what I mean by the service layer, how the service layer is going to be used. Because I described it, but I really want to show you guys the code now that you've seen the description, and maybe you might want to re-listen to the description after you see the code. So, for example, what I'm going to do here is I'm going to create a new package. Oh, well, let's go ahead and talk about what it is we're going to do. In the profile activity, I want to go ahead and write the event for the send temp file URI to server as new avatar. I want to go ahead and write this code, basically. So to do that, I need a request and a response class. I need two classes that are tied to each other, and they both have to do with the profile, and they both have to do with our temp file URI, uploading images. So over here on my package, I'm going to right-click, select New, and go to Package. And and I'm going to create a new package called services. Then inside of services, I'm going to right-click, select new, and create a new Java class. And for this this service class, I'm going to go ahead and create a class called account. Now, what's going to be interesting about this class is it's not going to be actually instantiated or used. I'm using this basically as a class that will hold a bunch of other classes inside of it. So I'm going to say public. I'm going to make it public final, and I'm going to give it a private constructor. So you can't actually instantiate this class. I'm just making it clear that this class just exists for grouping purposes, because I'm going to group multiple subclasses or inner classes inside of it. Now, it's also important to note that in Java, you can't have multiple top-level classes per file, so that's why I'm doing this. I'm doing this to reduce the amount of files that I need in the application. So, what do we need to do? We need to make a request and response class that corresponds with uploading our avatar. So what I'm going to do here is I'm going to say public static class, and I'm going to say change avatar request. And he's going to have a public URI, new avatar URL, or sorry, URI, to be more specific. And then I'm going to go ahead and I'm going to create a constructor that has that as a parameter. So here's our request. It's a class that has a public URI, new avatar URL, and a constructor that takes in that URI. Then I'm going to do public static class, change avatar response. And all the change avatar response here is going to do it's not going to do anything in this particular case. We're going to handle the event where our avatar is changed from other means through another event. This change avatar response, however, will be used to determine if the request completed successfully or if there were any errors. So this is a service call. We have two classes. So stop thinking about things in terms of methods and start thinking about things in terms of events. So we have this event, which would correspond to the parameter list of a method. And then this event, which would correspond to the return of a method. So how would we use this? Well, basically, go into profile activity, and on this to-do, what I'm going to do is I'm first going to show my progress frame, my avatar progress frame. So I'm going to say avatar progress frame.set visibility view visible. Then I'm going to say bus.post new account dot change avatar request, and then of course that decides to fail miserably, so we'll fix up the code there, and then we're going to pass in for our temp file URI, our output temp file URI.fromFile, and we'll do that. Then I'm going to remove these two lines of code. So what are we doing here? We're simply showing our avatar progress frame, our little spinny thing, our little progress bar, and then we're telling our service layer, go ahead and handle this event. So what happens when we're done? Well, I'm going to say subscribe public void on avatar updated account change avatar response, and in this case I'm going to say avatar progress frame dot set visibility view gone, and then I'll say to do handle errors. So this is how our application is going to interact with the service layer. So we're posting an event, we're telling, okay, service layer, go ahead and initialize your thread, do a network request, do whatever you want, calculate pi for all I care, go do something. Then when you're done, tell me about it. Now the awesome thing about this is, what if this activity was rotated, right? So it was destroyed and recreated. Well, guess what? It'll still work because this activity will... so activity A fires off the request. The request goes on a separate thread and let's say waits 5 seconds in order to return a response, so it hits the network. During those 5 seconds, the activity is just rotated, so it gets destroyed and unregistered with the bus, but then it gets immediately recreated and that new instance gets re-registered with the bus. Then, when the service layer is done doing whatever it needs to do, it'll post or publish this event. And when this event's going to be published, this new activity gets the information. So that's how we handle this thing. And it doesn't have to even be asynchronous. We could have a service layer that's completely synchronous, meaning when we handle this event, we immediately publish this event, and there's no additional threads. So this allows us with great flexibility with our service layer. Also, we don't have to worry about inversion of control or dependency injection or dealing with any containers, because we can change the implementation of our service layer simply by changing which classes handle this event. So again, don't expect this code to work. This code won't work yet. And the reason why it won't work is because we don't have any service classes that'll handle the account.changeAvatar request event. They're not going to handle it there because there's none that exist, meaning this event is never going to be published, which means the onAvatar updated method is never going to be called. We're going to fix that in the next video. Okay, so you might want to either watch the next video so you get a complete example of how this all ties together, or rewatch the intro to this video to get a better idea, maybe now that you've seen how this code's going to work, what I'm going with, or what I'm going for with this service layer. Again, I'm trying to keep the profile activity and all the rest of the activities only responsible for user interface logic. When they need something that's business logic-y done, if they need a network request or any other non-UI request to happen, they tell the bus about it, and then the bus will hook that event up with another class, and that other class will go ahead and handle it and return a response. All right, I guess we'll see you guys in the next video.